Now for connected rate of changes, I'm a strong advocate of using this chain rule here. So how do you do that? Is that, say if you're given, it's called connected rate of changes for a reason, because you're given a rate, and then ask how you affect the other rate. So let's say if you're given let's say DHDT, okay, then you ask to find DADT. Now if you want to find DADT, what you do is you just put DADT, use chain rule like that. Okay, usually one of the rate is given, so it doesn't take long for you to know that this should be your D. So say this is what DH, and this is DH. Okay, so I repeat, if you are told to find DADT like that, DADT, all right. So if you say this is DADT, then if you want to find, if you're given DHDT, this is DADT, so this will be DH and DH here. Then now, oftentimes area is not expressed in terms of height lah. So you know that you have this is given already. Then you separate again. Sometimes you may need to use chain rule again. So it depends. This will cue you to find A in terms of the height. So if A cannot be expressed in terms of height, let's say A can only be expressed in terms of radius, then you just put dr is split again. This will then prompt you to find A in terms of R, and this will prompt you from R in terms of H. Understand? Just use this chain rule here. It will just done. Yeah. Okay. So you look at this question here. So a total surface area of cylinder, right, with a fixed height of 3. So the height is fixed. The height is fixed. So this is not a variable, this is a constant. So if it's a constant, typically let it be a capital letter. Okay. If it's a constant, let it be a capital letter. So it's like constant. Okay, so you are told that the total surface area, dA dt, is decreasing at this rate. So just minus 5 cm square per second. So find the rate of change of the volume when the radius. So you want to find, so this is a surface area of cylinder. This is A. So volume. So dV dt is what you need to find. Okay, dV dt is what you need to find. You want to find dV dt when R is 2. So you start off with dV dt. You use this one, guys. Just like that. Just do this. D something over something dt. That's about it. Then what you need to fill in. Maybe. Is that okay? So I repeat, because we are given dA dt, then we are asked to find dV dt. Now you are told that the height here is fixed, so it's free. Yes, okay. You have got dV dt. So essentially you put dA here and dA here. If you put dA here, so this is fixed. Okay. Now we know that for a fact that volume we usually don't express in terms of area. So we use chain rule again for this one here. Just use chain rule again. And it doesn't take long for you to guess that this should be dr, because our volume usually in terms of the r and the h, but h is a constant, so it's fine. So this would then prompt us to find v in terms of r. This will prompt us to find a in terms of r, or vice versa. It doesn't matter. So then what we have is area is the curved surface area plus so this is a curved surface area will be here 2 pi r h plus 2 pi r square. Okay, the volume should be quite straightforward. Curved surface area is 2 pi r. Then once we're done, we just we know volume is just pi r square 3. Okay, that's it. So this once done already, you have dAdr is 6 pi plus 4 pi r. Then dV/dt is 6 pi r. Okay, you are given dA/dt, so you shouldn't use r here. You should put the dA first, then you split it up again. So once you're done already, dV/dr, you know that this is 6 pi r. dr/dt is actually just 1 over 6 pi r. dA/dt is actually just minus 5. Okay, that's it. This is it. So once you're done with this, this will be so then you just substitute the value lah. So you want radius as 2, so hence you only set the boundary condition at the end. So r equals to 2, 6. This is